Hello and welcome to another tutorial on dev.java website. And previously we looked at the first page of the dev.java, and now let's get started with learning Java. So this part that says get started with Java. Let's go inside. And the way they organize these tutorials is very nice. They have a outline of what you're going to basically read in this page or in this tutorial, which is very nice. So it has the outline of elements of a Java application, compiling and executing Java code, creating a first Java class, preparing the compilation of your first class, setting up a Java development kit or JDK, compiling your first class, adding code to your class to run it, running the Hello World program, which is a typical program when you first start learning a programming language as a single file application. And the single file execution or application of the Java files is something I believe they added in JDK 14 if I'm not mistaken, and then going further. So let's start with the getting started. Elements of Java application. I understand that you are eager to type some code in your editor and run it to see your first Java application in action. Do not worry, your expectation will be fulfilled by the end of this tutorial. But before we move on, I would like to do through several elements that you need to know to fully understand what you are doing. Even if you are familiar with some other programming language, know about compilation, know what an executable file is, you may be interested in the following because Java works in a way that differs from C or C++. Now what this means is that, so basically you go to your IDE, in my case Eclipse, and then you create a Java project. So the way different IDEs organize different Java projects or Java code differently. For example, in Eclipse organizes your Java codes as Java projects. And then you have a workspace, right? This entire thing is my workspace, and inside your workspace you can have multiple Java projects, and you can even filter them by working set. A working set is basically a collection of different a collection or a group of Java projects, right? So you right click new. If you are in the Java perspective, as you can see at the moment I have Java and C++ perspective. And then what happens here is that you right click new Java project, and then you give the name, where to put it, and we typically use the default location, which is the current workspace in use. And then you can set the execution environment, which is where so Eclipse uses its own Java compiler. It doesn't use the Java C that comes with the JDK. And I believe in the most recent version of the Eclipse, you don't even need to have a JDK installed on your operating system. That's just because Eclipse now also comes with the Java runtime. So previously Eclipse had its own compiler, but Eclipse didn't have its own Java runtime. But if I go to about Eclipse, and then let's look at the installation details. There should be a basically open JDK hotspot JRE complete. So what this means is that they have this just J open JDK. Basically they now include the entire open JDK JRE Java runtime environment into Eclipse. So Eclipse comes by default with the JRE. So it has its own Java compiler, but now it also comes with the JRE. So you don't really need to install a JDK. Now obviously if you want to work with different runtimes, or for example I have installed JDK 15, JDK 16, 17, etc. Now you can actually configure them and select different versions. So if I right click on my runtime and say properties, and then basically alternative runtime, these are the runtimes that are actually installed on my operating system. OpenJDK, Adopt JDK, GraalVM, Java SE, and etc. right? But if you use the execution environment, it just either uses the internal JRE of Eclipse, or basically the one you configure your workspace as a default. So basically if you go to preferences and then click on Java, and in the install JRE you can set one of these JREs as a default. And as you can see, one of this JRE 16, as you can see, this points to the Eclipse path, which means this is the one that comes by default. This is just J, OpenJDK JRE full. So by default, if you don't install any JRE on your operating system or any JDK, Eclipse uses this one that comes by default. But then if you just add more JDKs or JREs, then you can set them as the default for your workspace. And obviously, if you have multiple workspaces, you can set another default. So each workspace can have its own default JRE, right? Okay, but regardless of what JRE you use, Eclipse uses its own Java compiler to compile your Java code to bytecode, right? So Eclipse doesn't use the Java C. Now you can configure Eclipse or how Eclipse builds your project and what tools are going to be used. So if you right click and then go to properties, and as you can see, Eclipse offers this option, builders, and it says Java builder. This Java builder, basically the default builder that comes by Eclipse, which uses Eclipse's its own compiler. But you can create a new builder and then deactivate this Java builder. So you can say, okay, I want to build my project with a program, and then you give it the path here to actual Java C. The Java C that comes with your JDK, and then working directory in Eclipse, it's the way you configure the project by default. It puts the compilations in the bin folder, and then you can have arguments for your Java C compiler, and then you can select whether you want to refresh the project or the selected resource or the project when you rebuild, because Eclipse offers automatic builds. So if you go to build options, as you can see, you can also allocate the console whenever this build tool is run. Then if it outputs something to the console, you can also do it, and then you can launch it in background, and then you can also select that to run the builder during automatic builds. And automatic builds means if you make some change to the Java code and hit the save, Eclipse in the background basically runs another quick build. And note that the Java compiler of Eclipse is very fast, so you don't really feel that the project is rebuilding, but behind the scenes Eclipse is actually running builds as you save your Java files, and then your class files are already compiled, everything is ready, and you just hit the run and then you run it. So for example, if I do something here and hit save, Eclipse quickly recompiles this Java class. So if I say sysout, for example, testing, and hit save, you see if you make lots of changes, you see that there is a progress bar on the right lower right corner, and see that there's some rebuild happening. You can manually rebuild your project, so build automatically, this is selected, and then you can basically just clean it and rebuild it, right? There are options here, source, refactor, and then refresh the project or rebuild it. You can do this kind of stuff. So yeah, one thing that I mentioned, so here they mentioned that so as you already know, if you are familiar with Java, you know that the Java compiler, the way Java works is Java compiles your source file to an intermediate format called the class files, right? So if I go to navigator and then look at my dev.java, as I mentioned, the default organization, the way Eclipse organizes your basically project is you put the source files into your src folder, and Eclipse compiles them and puts them in the bin. And the bin and source, they have the exact hierarchy. They should, right? I mean, the path should be exactly identical, but the bin folder includes the class files, right? And then Eclipse keeps track of the class path in this XML file, and the project is for the build. Let's look at the source. This tells the Java builder that comes by default with Eclipse how to build. What is the build command? So it uses JDT, Java Development Tool, which is part of Eclipse core, and builds and says that this project has a Java nature. The class path is just keeps track of which folders to include. You might have added additional jars in your folder. A project in Eclipse can have basically dependency on another projects in your workspace. So Eclipse keeps track of all of these, right? And at the moment it says that the class path entry is basically just the bin. So this is the top folder or the root folder of the class files. So when you run something from the Eclipse, so if I hit run, Eclipse automatically runs the Java tool, right, from JRE, but it also sets up correctly, sets up the class path based on the information that is in the class path file, right? Otherwise, you have to be careful. If you want to manually run Java on your application, you should always be careful about what's on your class path, what classes are needed at runtime. And that's the beauty of IDEs. They hide all these details, because then you're just focused on writing your code, right? You just focus on writing good code, and IDE takes care of the build phase, etc. Now in C++, you have to go through the compilation, and that's typically explicit. You write your code and then you explicitly invoke the compiler, and then what happens is it directly compiles to the machine code. Obviously that's platform dependent, and we know that the Java offers platform independence through the concept of JVM, a virtual machine. Compiling and executing Java code. There are several steps that you need to follow to create a Java application. This tutorial shows you how to create a very simple Java application. If you need to create an enterprise application, the creation process is more complex, but at its core, you will find these simple steps. So when this says enterprise application, it usually means a web application, and you have to have some sort of other. So when you say new Java project, if I click on the other types of project, you may want to run some other specific projects. So instead of having a plain Java project, you might want to create, for example, a web application, etc. Right? So I mean, enterprise here, it mainly means web applications. And then again, the process is very simple. You create your project, you add your package, put your Java code here. Eclipse automatically compiles everything, keeps track of the build path. You can even convert this project, for example, to a Maven project. And if you're not familiar with Maven, Maven is a way of managing the dependencies of your code. And Maven is also a build tool, but Maven doesn't come with its own compiler, right? It looks what Java compiler is on your path of your operating system and invokes them. So Maven is mainly officially Maven is called a build tool, which means it knows how to use different tools in the JDK like Java compiler, etc., to compile your application. But then Maven is also very good for managing your dependencies, because it can connect to the Maven Central, which is an online repository. There are a lot of jar files on the Maven Central, and then it can download them, add them to your class path, right? So Maven is very good. I will have tutorials on how to use Maven. So if you're not familiar with Maven and you want to learn Java, definitely get into habit of using Maven, because that makes life much easier in terms of managing dependencies. Because especially if a project has lots of other dependencies, something like a Spring Boot, for example, you have to really use Maven, because Spring Boot has a lot of dependencies, and it would be very hard to go and download all the jar dependencies manually and add them manually to your class path. Instead, we just tell Maven, okay, add a Spring Boot, and Maven automatically adds all the dependencies, right? Remember, at runtime, you have to have, even at compile time, you have to have all the classes on the class path available, right, to the Java compiler and also Java runtime. Unless you're using a dynamic loading, which is typically not recommended. So dynamic class loading is, you say class for name, and get the class. So this returns a class, and then you can, for example, so dynamically look, this is where at compile time the Java compiler doesn't care about it. Obviously this can throw lots of exceptions, so let's throw so this completely bypasses any requirements that Java compiler asks for. So this bypasses Java C requirements, right? Because Java compiler sees this and says, oh, so you want to dynamically load this class, no problem. And obviously You have to specify the fully qualified class path here, and the path separator is forward slash, not dot, right? You can also use dot. I believe both of them will work. And what happens here is that then this returns a class, and then you can use the constructor using reflection to construct that. So you use reflection and dynamic class loading, and obviously the only error that might happen is at runtime the Java JVM may not be able to find this class. So if this class is not available on the class path, then it's going to cause trouble. And the other problem is that if you really want to work with this, you see this returns a class of generic type or wildcard type. So then what happens here is that you kind of need to cast it to a particular type that you want. So a lot of unchecked warnings might happen. So it's better to avoid this kind of dynamic class loadings. And for the static class loading, obviously that class must be available on the class path even at compile time, right? Because Java is a statically typed language, so compiler needs to check that if you're working with a particular type, a class, then it has to know what methods are available, which ones are public, private, etc., right? So the first of these steps is to write some Java code in a text editor. And again, just forget about a plain old text editor or this kind of stuff. Just go and use an IDE. That's way better. Basically, the first and most important rule about Java, even before learning Java, knowing how to write good Java code, know your IDE. That's the number one rule when you're doing C++ or Java programming. You have to know your IDE very well. You need to know how to set up external tools, for example. If I want to, for example, invoke Java Edge, which creates the header files for my native methods. So you have to learn how to do things outside the terminal, right? You want to make sure that you understand your IDE very well. How to debug stuff. What is this terminal? How do I open quickly a terminal here? I just select the file and hit tab. It creates a terminal right here, right? If I do ls, it says test1.java. So I'm inside this package and I can do stuff right inside. So Java test1, and as you can see, it can run it without any compilation. This is part of the single file application that they added from JDK 14, I believe, and I'm using JDK 15. So as you can see, you have to know your IDE so that you know how to quickly get around, right? What are the capabilities of my IDE? Let's say I want to change basically the name of this variable. So I have to know how to quickly right click on it, say refactor rename, and the IDE is smart enough to change the name, right? To know all the instances of this variable in this Java file or in any other Java file that I'm using it. And so IDE is very powerful. So just forget about text editors. This is not relevant for Java. Maybe for Python, that's a possibility. For Java, forget about a plain old text editor. Then this code has to be transformed to another format, which is class file, right? So Java compiler, the job of the Java compiler is to compile your Java code into actual bytecode that the JVM understands. This transformation is conducted by a special piece of software called a compiler, right? Some languages do not have a compiler. They just purely interpret the code. Java does, and it does it on a couple of levels. Obviously, the first level is a Java C. It's a static compilation. Also, at runtime, Java has the just-in-time compilation, which is more about optimization, runtime optimization. Every compiler is specific to a language. And then the file produced by a compiler is often called a binary file or an executable file, whereas you can read the source code and understand it. Binary or executable files are not meant to be read by a human person. Only your computer can make sense of it. Now, in the case of Java, you can actually decompile a class file. So this is my class file. If I open it in Eclipse, let's just open it. You see it says source not found, so it doesn't decompile into source, but it tells me at least a readable format of the bytecode. This is actually the instructions that are given to the JVM. It says there is a method constructor, and there are three instructions here. A load 0, load a reference object, which is this, the first pointer for any non-static method, and constructors are never static. So the very first instruction is always load this reference. This is implicitly passed. And then invoke a special, which is the constructor of the superclass, in this case object class, and then return. So 3 instructions for this method. And then we have a main method that takes a fully qualified object, which is Java lang string array, and then args, and then it has a couple of instructions, 1 2 3 4 5 6 7 8 9 instructions. LDC, a store 1, and then get a static, LDC, invoke virtual, get a static, a load 1, invoke virtual, and then return. And also it takes keeps track of the program counter, PC, and then local variable table. And if you are also having exceptions, then it also keeps track of the exceptions handling and exception tables. So this is the general idea of a bytecode. I highly recommend you get into the habit of reading the bytecodes from the class file. It tells you how many instructions are needed for that particular method to be computed or to be completed. And obviously the fewer methods you have or the fewer instructions you have, but in general your method will run faster, right? And then so executable, this code contains a special binary code called the bytecode. This is for the class files of Java. This is a technical term that you may come across. The precise description of what is this bytecode is beyond the scope of this tutorial. So the bytecode are just basically the instructions given to the JVM. Compiling some code may fail if you have static errors. So if let's say I make an intentional, this is a syntax error, right? Not semantic error, syntax error, and immediately I made the change, immediately the Eclipse compiler tried to compile and realized that there is an error, and it also gives us the error. So Eclipse is very intelligent in pointing out your static errors. And this is one beauty of statically typed languages, because once there is no static error, means there is no syntax error, which means at runtime the only errors that you might occur are either dynamic loading of classes, something of that regard, or semantic errors, right? The logical error of the code. But then the JVM doesn't need to, at runtime, it doesn't really need to worry about whether you have a syntax error or whatever, because all these checks have already been done, right? So in compiled languages, there is no, after the phase of the compilation is passed, there is no syntax error, and then the runtime doesn't need to worry about this kind of stuff. Do not worry, this page gives you the code you are going to compile. All you need to do is copy it and paste it in your text editor. Once the compiler produces the binary file that you need, you can execute this binary file that will your program, right? So your program will execute. These 2 steps, compilation and execution, require 2 specific pieces of software that are part of the Java development kit, also known as the JDK. You will see how to download the JDK for free and how to install it later in this tutorial. Note that starting with Java SE 11, you can also merge these 2 steps into one by executing a single source code Java file directly. You can use this feature only if you are executing a program that is written in a single file. This way of executing your Java application does not work if your Java code spans more than one file. So this is so they added this to the Java tool, right? And when you invoke Java on a Java file, it's a single source executable. It just behind the scenes, it compiles the Java, caches the class file in the memory, and then runs that class file, right? So there's nothing magical about this. It's just for a single source file. And the reason that it has to be a single source file, then that means there is no class path dependencies. Otherwise things get complicated, right? So they wanted to avoid this kind of complications and make it really simple. You just say Java, this Java file, and then it shouldn't worry about the class path dependencies. So I hope you enjoyed this lecture. In the following lectures we continue going through all these items, and I'll give you more details about how to work with Java. Please stay tuned, and I'll see you in the next one.